Assalamualaikum. I want to welcome all of you here for yet another tutorial of C language, and regarding this is array and pointers. So this is just an introduction for array and pointers. What I'm gonna do here is I'm gonna create an integer array AR of size say 5 and 2. I will initialize it right here. It's a two-dimensional array what I'm actually talking of. Maybe I have got the values 11, 12. It's the one row, and second row maybe I got 13, 14, and the next row I got 14, 15. Maybe I will take it right now 3 rows, so I'll change it here 3 rows. If you look at it, I'm having 3 rows with 2 columns. So this is row number 1, row number 2nd, and row number 3rd, each having 2 columns. So it's a two-dimensional array which I initialized here. So it is declaration because I said int. It is a definition because I created a variable, and it's also the initialization. All the three in a single line. Then what this AR stands for here is, this stands for the address of the base address of the first row. If you are confused with this, maybe I will also create here a one-dimensional array. So let me create a single dimensional array AR for example of size say 3, and in it I got the values. For example, I got 1, 2, 3. The 3 values I got here. If you could see, the ARR here is this one-dimensional array. It is the ARR variable consists of the address. It consists of the address of this base address, actually, of the first byte which it occupies. That means the address of 1. It has the address of 1. Similarly, if we have this two-dimensional array, it has the address of the base address of the first row, first byte, first row. That means this 11. So that means it's actually a pointer. This ARR or AR, the array name, they're special variables. They are not just variables and ordinary variables. They are actually pointers to the memory locations. So they consist, inside them is the address. So we're going to take it like that. So if we say printf, for example, let us see the difference. %d, comma, maybe the first percent backslash n, maybe %u. I want to print the address. That's different done with the %u, and %d, that's the element. And I'm saying the address, that's I say the name ARR first of the what is that one-dimensional array, then ARR of 0. Okay. Now, second thing which I want to print about the two-dimensional array. If you look here, I would say the printer. This time \n to get it. New lines already there. So okay, \n. I say %u. Again %u. Okay, and \n, comma. In the first I say AR, and then I say AR of 0. So I'm printing here AR and AR of 0. So let us see what we get in. So I will write the getcha to get the user screen and the program, a very simple program here, and I will try to run it. Control F9. There's 2 errors. So what else? I got 1 error here. So whoops, it's actually a night time, 3:56 a.m. so maybe a little bit busy. But what's the second error? Let me try to run it again. Control F9. There's nothing. So if you look at it here, I got nothing, sorry. If you look at it, the output, this is 65520, the address, and then the element 1. But next time what I see 6508, 6508. What's that? That means that's my error %u here. You might have thought I have done something wrong, but it was not something wrong. But actually what happened is AR of 0 here and error of 0, there's a difference. This error of 0 will give me the element 1, but this error of 0 again give me the address same as the AR, because in a 2-dimensional array you need 2 indirections, because it's an array of arrays. Actually the first indirection will get you to the first base address, okay. The second indirection will get you to the what is called as the element. So if you want to get element here, you cannot say AR of 0, rather you're going to do something different. You have to tell them 2 dimensions, both 0 0 maybe, okay, because it misses 0th element, 0th row. So let's try to run it now, and it's giving me 11. Now it's giving 11. If you see, previously it was giving address, now it's giving 11, because for 2-dimensional arrays I need 2 indirections. One to go to the address of the row, and second indirection to go inside. So if I don't write it, I write it like this, like a 1-dimensional array I write, but 1-dimensional array needs only 1 indirection. So I need AR already has the address, and AR of 0 will give the element, what's at the value at the address. But AR of 0 in 2-dimensional array will give again the address. That's the one point. And if you write AR of 0, if you write it like this, like a pointer, you can understand better what I was talking of. I will say asterisk AR. Now asterisk is the value at address, but it is single indirection. This 2-dimensional array is like pointer of pointers. So I need double indirection to get the element. Single indirection will give me the address only. Let's check it out. So here we go. It's giving me only the address. But if I say here asterisk double indirection and run it, it gives me the element. So the moral is that 2-dimensional array is like just pointer of pointers, so we need 2 double indirection to get the element, rather than in case of these, we'll say 1-dimensional array, we just need 1 indirection. So if we say in like pointers here, for example, I will not use this bracket scheme, I will use the indirection operator to get it. It will get me the element 1. So Control F9, it's giving me element 1. If I want to get the element number second, I got to increment this. Okay, I could say asterisk AR plus 1, and here I could also say asterisk AR. Let me see what will happen here. Plus 1. Let's check it out first. Let me clear the screen now, so that I could see in a better way. Now look here. It's giving me the element 2, it's giving me the element 12. So I have progressed here. Element 2, element 12. Because I say asterisk AR plus 1, asterisk AR plus 1. Can I do plus plus like this? AR, I got ARR, then I say plus plus to give me the value. Control line, let me see. Let me show me there. Why? Because ARR is a pointer, but it is a constant pointer. That means it's pointing to the base address. You cannot increment it, means you cannot change its value. Rather, you can calculate an offset. We say ARR plus 1. That means where ARR is, what is the address of ARR, plus 1 to that, and give me that's the address of 2 here. Give me the value of that. But don't change ARR. It's like that. But if you say ARR plus plus, this means we're saying compiler, change the value of ARR to the ARR plus plus, then increment of 1, and give me the value of that. But it cannot increment ARR because it's a constant pointer. This is what is the difference between the normal pointers and array pointers. Okay. And asterisk asterisk ARR plus 1 will give me the what? The element, that's the second element, and so on. I could have done one more thing, that I could have used it like this here. Not saying how many rows actually, only saying the columns. Will it work? Let me see. Control F9. It's working fine. Because in two-dimensional arrays, what necessary is the second, that's a row. If obviously I'm doing initialization here, but if I'm doing initialization somewhere else, then I need both dimensions. But right here, I need only one dimension, that's the columns. Because if we omit the columns, it will get messed up because it knows nothing. Which one is the row, which one is the column. If you try to run it, let me see. It is showing me 4 errors. In fact, because he will say such type is unknown or 0, because what we need to know here is the rows or columns. Yeah, columns. Rows we can calculate, but columns I need, because for that reason, when I'm gonna display this, or I will say this is the row number 0, column number 0, row number 0, column number 1, row number 1, column number 0. So rows, when you say AR address or AR, it is already having the address of this row, so pointer to the row is already there, but I need something, some information to tell compiler where I can go for this rows. So rows are important to say here. For example, here I don't require to say 3. It can take up, because we got the address of this one. Rest, it can go up in a line to say, yeah, these 3 are after the 1, after 1 there is 2, there is 3, and 2 bytes are there after 1. It can get on there. But here it's not in a straight line actually. They are actually placed in the memory in a straight line, but somehow we have to give that information to the compiler, that where our rows stand. So if I run it without initializing and giving here the value, it will run fine. It's running fine, no problem. So okay. So it is all about this, and if we do a little bit of different thing here, if we calculate address here, we could have done the value AR of I. We have done it asterisk AR plus 1, also like that. If we calculate here, like I've shown you this thing. If I say AR 0 plus 1, like this, a different way of doing things. AR 0 plus 1. Now AR 0, you know, it gives me the address of the first row, and plus 1, it gives me this will act as a column. So you're taken to the column, actually column 0. Will it give the 12 or will it give the address? Let's see. What happened? Control F9. It will give me the address. 6508 was the address of the first address, that was 11, and the address of 12, that is 65510. So it's giving me the, because this error 0 is the address of the first. It's like saying asterisk AR, it's same. So I could make a comment here so you can understand it. I'll say AR of 0 is equivalent of saying asterisk AR. Understand? So if I say AR of asterisk AR plus 1, or we say AR of 0 plus 1, this is one and the same thing. If you're gonna get something like the value here, so I have to use indirection outside maybe. First calculate the address, then give me the value at that address. Because this wait a sec, yeah, because this AR of 0 plus 1 is now give me the address of the 12, and maybe I will say here 2 for example, or something like that. This is the address of 12. Now if I use the asterisk in front, it tells me the value at that address. That means definitely what? The value 12. This time around it gives me 12, not the address. Understand or not? So we are actually done with this two-dimensional array and how it was located and how the values are given here. And now it's time to actually pass these two-dimensional arrays to the functions. And there are actually 4 ways to pass two-dimensional arrays to functions. One is pass arrays to arrays. Second is pass array to pointers. Third one is pass array to the one-dimensional pointers. And then last one, the fourth one, is the pass arrays to two-dimensional pointers. Let me demonstrate all the 4 here. So maybe I will not use these things now. I have to pass, and I will pass by all the 4 ways. First I will say here something like, I got this now. I will say int I comma m comma n. I use them, and maybe I use a pointer value as well as for example j, maybe I am n and asterisk j. This means it's an integer pointer j. Then I will call the show, which will print me the things, the array which I have here, two-dimensional array. I don't need the one-dimensional array as well here. I will close it. And the show here, you could see, I will pass it the AR and maybe the rows and columns, m comma n. I will say that I have to say this m and n somewhere. Maybe m is equal to, say for example 3, because I have 3, and n is equal to 2. This m is equal to 3, and rows and columns are equals 2. I'm passing them to the array called show. Okay. Now second function, I will say maybe I will say a different name, because this is I'm passing array to array. Maybe now I pass array to the pointer. I will commit it. This is array to array. Okay. Pass array to array actually. Now I'm passing, let's say print that, print, print, and I pass again the value AR and usually m and n, but this time I will pass array to, what's happening, array to pointer. Okay. Third will be display, and in display I should say display, not display. Yeah. So I'm passing here and only the rows. Okay. And this I'm saying says array to one-dimensional pointers. Okay, then I will say exhibit, and pass AR and as well as that again, but this I will pass to array to two-dimensional pointer array. So again the pointer array. This will understand when I have to use this as a comment. Can't use like this, is it? Okay. And there is a getcha, and I will call them somewhere. If I use it downside, I have to use prototypes later on, so I will use them on the upside before the main. This is only to avoid the. So first is the this show ARMN, and this is what I will write here, show, and I'm saying int. I'm putting it in the int b, and something like this. So comma int l comma int p. That means this m will go to the l, n will go to the p. Okay, maybe I will say row and column parallel. Row and column. Okay, let's go to the R, let's go to the C. This m will go to the row, n will go to the C, and I got this array here. Int b is a two-dimensional array. I'm saying that is this AR will go into the B, and that's how I define it. Now I got here something variables. I need I local variables. These are I and j. So printf, this is the show function, is it? This is show show. What's happening? Backslash n. Okay, I will use a for loop for I equals 0. I is less than how much? I should say L I plus plus. Okay, what should I do here? I should printf percentage d backslash n. I will say backslash n, and it is the b of I. Maybe then I will say 0, and b of I 1. Okay, because I got only 2 rows, so 0. I could use it for j variable to give us the variables for rows, column, sorry, but I need only 0 1, so I'm doing right away like this to make it a bit simple. Okay, now I'm closing it. This will give me, and I'll close this show function here. This will give me the value of the two-dimensional array which I have passed here. Show. This is passed to array because this is array is again the array. I'm passing array to array, and I'm passing it AR will go into the B, nothing like that. And rows and columns I'm passing here so that I could access inside how much I have to go. I should know inside what are the rows, how much rows I have to access. So that's why I'm passing the M and also the N, whatever. And now second thing I will do, which I've said, the print function, which will actually print me what? print. I'm trying to pass it to the pointer. So I will say print, I will say int asterisk b, or b I used to have to b, int asterisk b, and I got int have I said here L or I said R? It's R after row, so I think I should say R here. Yes. Now int row comma int column. Okay. I will again use here int I comma j, and then what? Again the for loop, but I will say printf first. Maybe I copy this here. Shift insert and here, copy it here. What's happening? Okay, so this is my print now function. I should say print rather, not show, which is all the pointers. Now as for I is equal to 0, I is less than R, I plus plus, print me percentage d b of, but this time around I got the pointer here, asterisk b, so I should use asterisk b to print me the addresses, or actually print me the values. So I say asterisk and bracket, and then I say b, and I will select this plus I 0, so b equals 0. It will give the first row, but it is a two-dimensional array, so I cannot use only the, I should say into 2, plus 0, like that. First element. Then the second one is the again asterisk, then b plus I into 2 plus 1. So maybe you understand that is what I'm doing, because I want to print the first row, column number 1, column number 2. Similarly in second row it will be I, which will tell us whether it's the first row or second row. If it's the first row, for example, that will be of I will be 0, because b plus 0 is b, that will be the first row, and this will give us the column numbers, because this is telling 2 plus 0 is 2. That means column number 1, and this will give me row 1, column number 2. 2 plus 1 is 2, because it's giving me second, it's giving me second column, and so on. So